So like I was saying a minute ago before I hit record, we're going to be using these values to break down radicals. So these perfect purples that I kind of call them are going to be the ones that break down, because in actuality they're perfect squares. And by a perfect square I mean I can take the square root of any of those numbers that I just highlighted in purple and it comes out nice. It doesn't come out as a decimal or something like that. So those are going to give me the most flexibility. So here's what we're going to be doing. Because in math we like to have things be exact. We don't like to round as much as humanly possible, because when we do, we're not quite as accurate. So let's say we're trying to figure out a way to break down the square root of 50, because we're going to get into some equations and stuff where we need to find exact answers. So I start looking in the table for where the 50's at. And I happen to find one right here. And I'm saying, okay, so the two numbers, when I go out to the edges, that have that particular value is going to be what those two numbers equal. So for instance here, 50 is 25 times 2. I noticed that. 25 is one of my perfect purples, one of my perfect squares. So I could break that down and it equals 5. But then the other number won't break down. It's got to stay in radical jail is what I like to call it, because it's not having perfect behavior. So here's how this is going to work. As I'm doing these, if you know two numbers right off the bat that multiply to get 54 and are one of these numbers, awesome. If not, there's two options you have. You can either go looking for the number in your chart, and if you find it, look at the two numbers that multiply to get it. So in this case, it would be 6 and 9. But then I'd have to take a look at those two numbers and say, okay, which one of them is perfect? Which one of them is in my perfect list? Well, 9 is. Okay, so I'm going to use my other color to make its radical, because that's going to remind me that one's going to break down. Well, what is the square root of 9? It's 3. So because it's perfect, it gets out of radical jail with a new identity. Okay, witness protection program here. It's out as 3 now. Never will recognize it. 6, however, math joke coming, is acting irrationally, so it has to stay in radical jail, and I'm done. There's not a lot of length as far as work goes to these, but it is going to be something where you've got to get used to either using the chart or using your mental math, or you're like, what if I lose this sheet sometime and I'm trying to do this? Can I do it without the sheet? Sure. Here's what I'd suggest doing if you happen to misplace the sheet, before you get another one from me, of course. I would take that 54 and I would start trying to divide some of these numbers in the radical in there. So you're like, okay, well, of course it'd have to be a smaller number. Well, I wonder if 36 would work. So maybe you'd try 36. No, that didn't work. Well, maybe 16 will work. And what you would do is you'd keep working it. No, that didn't work. I wonder if 9 works. Oh, it does, 6. And then I could say, there's my perfect number, and I'm going to be able to break it down. But here's where this can get a little bit more complicated, just a little bit. 72 is my next one. So I start to look in the chart, and I say, okay, there's 72. Oh, wait a minute. There's 72. Well, but here it's 8 and 9, and here it's 2 and 36. Well, what do? You always are going to take the biggest one, and I'll explain why here. I'll show you what happens when I do it each way. So if I use the 36 and 2, so I'm just going to write this down twice so I can see the difference here. Whichever one's the perfect square. Okay, this are in my purple list here. I'm going to give it the different color because it's going to remind me that one's got to break down. The square root of 36 is 6. And then again, one will break down, one won't. I get my answer. You're like, okay. But what if I didn't see that? What if I just used the first one I saw? And the first one I saw on the chart was 8 and 9. Okay, well, let's see what happens. I notice the 9's the perfect square, either from here or from in my chart. So I break that down. And I'm like, well, okay, 3 square root of 8. Why am I getting a different answer? actually, surprisingly enough, you aren't getting a different answer. They're the same thing, and let me show you. So 6, if you're trying to get a square root in these calculators, you're going to hit second and x squared. We'll make a note of that. So second and x squared will get me the square root if I wanted to check something. So if I do 6 times the square root of 2, I'm going to get a funky decimal, okay? But then if I plug the other one in, 3 square root of 8, I get the same thing. So you're like, will you take either of them as an answer? No, and here's why. This one isn't completely simplified yet. You're like, well, wait a minute, what do you mean it's not simplified? Can I find 8 up in my chart? Oh, wait, yes, I can. Oh, I can break it down more then. Okay, that's what you're talking about. So if I don't take the biggest one, always look to see if this number that's left under here is in your chart. Because if it is, we've got to break that part down again. And nobody wants to have to do it twice. I mean, shoot, I wouldn't want to do anything. Well, certain things, I wouldn't want to do them twice. Square root of 4 is 2 square root of 2, but then I'd multiply it by my 3 that's already there. So see, I can get the same answer, but I mean, let's look at the work involved here. I think this one's better. So whenever you're looking for a number, trying to think of one that divides in, always think bigger numbers first, even if you're just playing with the calculator trying to do it. The bigger the number, the better off you're going to be in trying to get those figured out. So okay, I want you to help me out on one here, and I'm going to have you guys kind of dig in on one too. So with the next one, for example 4, we've got the square root of 96. Do we see 96 anywhere up in the chart? And if you do, what are the numbers that go along with it? 16 and 6. So out of that 16 and 6, which one's the perfect one that breaks down? Pull this back down a little bit to help us. Look for the ones that are under the square roots there. Which number do you see? $16, okay? We're looking at these, either the ones that are in the left side of my chart, okay? Those and the numbers that are under the radicals, they're the same numbers. Those are the ones I'm looking for, because those are the ones that are going to break down perfectly. Okay, the square root of 16 is 4. Out of radical jail, and we'll talk about the importance of that in a minute, and then the other one doesn't break down. Now, some of you may look at that and will say, well, wait a minute. That 4 is a perfect square, so do I break it down again? No, because notice the 4 is not under a radical. It's not in radical jail anymore. He's free. We don't need to change him anymore. He's become a new number. None of the bad stuff is left. So that one's just going to be done. Now, let's see here. 200. What do we have for breakdown? What do we have? What do we have? What do we have? I know I'm seeing one. Okay, 25 and 8. Are there any other ones? 102. Which one do I want to use? So I've got 25 and 8, where 25 is my perfect square. Or I've got 102, where 100 is my perfect square. Which one do I want to use? 100, because I always want to use the bigger one, because otherwise I got to do twice as much work. So we're going to go for 100, and we're going to go for 2. And then the square root of 100, I look up there, is going to be 10 times the square root of 2. And I'm set. It takes some practice. I'm not going to say it doesn't. And again, The chart makes it easier. The calculator's doable. So now, here's what I want to show you that's going to kind of go along with this. And then I'm going to kind of work some worksheet stuff with you. There's one more part to this. So this other part that's kind of a note sheet for what we're doing is we've got to learn how to take things that are written as an exponent, make them a radical. If they're a radical, make them an exponent. Because depending on what we're trying to do with it, sometimes it's more helpful for it to be in one way versus the other. So up at the top, I made a note for you. Whenever I've got something in an exponent form, the exponent's going to be my number on top, and what's called the root, like when we do a square root, okay, is going to be what's in here. So when I go to express this as a radical, okay, I'm going to put whatever's in the parentheses inside my radical. Whatever's on top is my exponent. So I'm going to put that outside as my exponent, and my root is going to be the little number that goes in here. And that's all you've got to remember with this. Exponent goes outside, and it's my top number. Root goes in that little spot in there, and it's always the bottom. And that's the same whether I'm doing it with something like this or if it's just R. Same thing. Exponent's on top, goes outside. Root's there, goes inside. And if you tend to get mixed up with that ever, the way I remember it is, exponent comes before root in the alphabet, so whatever comes first is my exponent, my root comes second. And it just helps me out. And again, whenever I'm doing these, just a radical, whatever's in the parentheses goes inside. My exponent goes on the outside, and my root goes underneath. And we just keep working those. So let's see, we've got x, exponent, root. One more here just to be sure. Exponent, outside, root, little number in here. So what we're going to do in the next section is kind of interesting because we're going to undo what we just did. We're going to go from this radical form and we're going to go back to the exponent form. So, for instance, when I get down to 9 here, I am going to make note of one thing that I have up here. When you have a square root, your little root number on the outside here is a 2. They normally don't write it. I'm going to write it every time, though, just to remind myself. So this should be a little 2 right there. So when I'm getting ready to go write this, now whatever's under the radical will go in parentheses. And remember, it's exponent over root. And now it's back into an exponent form. So all I'm going to do, again, whatever's underneath the radical goes inside. I don't see an exponent, though, on this one. What's the exponent if I don't see one? 1. So really, this would look like this. Exponent over root. I'm done. Ooh, it doesn't seem tricky, but it is. Okay, I get to do the easy part, 5n. What's my exponent going to be on this one? Because I don't see any numbers. 1 over 2, because I remember, oh yeah, the exponent's 1 if I don't see it. The little root number's 2 if I don't see it. Fun, fun, fun. Let's do a couple more just to make sure. 13, I get the easy part again. What's my new exponent going to be? Two over 3, because it's exponent over root. 14, Harty gets the easy part one more time. What's my new exponent going to be on 14? 5 over 2, because that's what this is. Okay? So now, We've got some breakdown. We've got this. Now, what are we going to do when it actually comes to the assignment? Well, grab one of these. We'll keep our help sheet handy here. So here we are looking at homework check 7, number 2. So I think we're probably looking at Tuesday, Wednesday, next week probably as a homework check. The first part of this on the front is just what we just got done doing. Okay? Write the expression in radical form. So all I'm looking to do is my radical, put what's in the parentheses underneath it. Now the question becomes, what number is going to go out here? 2, because it's my exponent. And it leaves my root for in there. And that's all I'm doing. That's it. I just make sure, get a little practice, get that set, I'm good. When I get down below, it's just the opposite. I write whatever's in the radical back into the parentheses. And what's my new exponent going to look like? 5 over 3. Exponent over root. We're good to go. It's just writing them back and forth to get used to what the form's going to look like. How would we do number 10? Okay, let's move up a little bit. So I got my n. Now just because they didn't put parentheses, this would still be my exponent on this one. So if that's my exponent, what am I going to be putting out here? Exponent over root. Yeah, just because they want to put it inside doesn't mean that it disappears. And then when we get to the back, this is where the breakdown's going to start. This is going to be the stuff that we're going to be using to solve expressions and simplify terms and all this other good stuff. So I'm going to move this down just far. A lot of these because we're going to need a lot of practice with these. So, all right, we're gonna play with a couple of these here. Number 1, good place to start. So if I've got my 175, we got to break that down. Now again, if you happen to misplace your sheet, I always can use, my perfect squares and try to divide in. But like we said before, I always want to try to find the biggest perfect square that goes in. And if you're not sure, just start from the top and just start trying to divide until you find something that goes in nice. And if you're not sure, you're like, yeah, I don't think, maybe 49? Whoa, helps if you hit divide, doesn't it? But you just try to divide those in until you find something. Oh, wait, I think it's 25. Oh, yeah, because there it is right there. So once I find that pair, either with the calculator or with the chart, I write those two numbers down, which would include the number I divided by and the answer, of course. Then I say, okay, the one that's perfect, square root of 25 is 5. And then the other one doesn't break down. It stays in radical jail. I'm done. Nothing too terrible. Sometimes I may get lucky. Check out 14. Wait a minute. Square root of 100. That's a perfect square already. It's just 10. Yeah. You may get some that are just the perfect square right away. You may not even have to break them down. It just depends. But then, of course, I always have to throw some twists in because that's just how I work. So the last one, at least for now, that I think I'm going to do is 19. Roll down to 19 here. Wait a minute, what happens when there's a number in front? We'll deal with the number in front in a minute. Right now I just want to deal with the 32. Chart or calculator, I need two numbers that multiply to 32, but one of them has to be a perfect square. 16 and 2, you even got the biggest one. Excellent. The 16 is my perfect square. That equals 4. And again, once you're out of radical jail, you're not getting broken down anymore. We don't need to break you down anymore. You have changed. You have become rational. The other one won't. But that negative 4 is still hanging out. So the guys that aren't in radical jail anymore, the negative 4 and the 4, I can multiply them. Then I'm done. But it's critical, 11 through 26 on the back, that you can break these down, because we're going to start solving equations where we have to break them down, combining like terms where we have to break things down. It's something you just got to play with, and start with the chart, and you'll be shocked at how quickly, once you start using the chart or playing with the calculator more, that those numbers just start popping into your head right away. You'll see 72 and you'll be like 36 and 2. And you'll be able to do them quickly, but you got to put in the time at the start to make it work for you. So use the rest of your time, get some of that stuff set.